All right, geometry students. So today we are getting into our several part lesson series about types of triangle congruence, how we can prove triangles are congruent. The first two methods we're going to look at are side, 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 and side, angle, side. In this lesson, we will be reviewing basically the definition of congruent triangles. We will also talk about the side, side, side congruence theorem and proofs, and side, angle, side congruence and proofs. So make sure you have your notes open and let's get started. So first, let's touch base on what congruent triangles are and how we make congruence statements. So congruent triangles have the same shape and size. This means that all corresponding parts, meaning the angles and the sides, all three pairs of angles, all three pairs of sides, are congruent. When triangles are congruent, we can write a congruency statement. You can see that with these two triangles shown, we can write the statement triangle ABC is congruent to triangle DEF. And the order matters in this statement because, as you can see, angle A corresponds to angle D, angle E corresponds to angle B, and angle C corresponds to angle F. So the order matters absolutely. So now, if all corresponding angles and sides of two triangles are congruent, then the triangles are congruent. However, you can prove triangles are congruent using fewer parts, what I like to call shortcuts. And the first shortcut we're going to look at is called side, side, side congruence. And so this congruence theorem says that if three sides of one triangle are congruent to three sides of another triangle, then we can say that the two triangles are congruent. So we've got our diagram here. So if, let's say, for example, with this diagram, let's just start with the first tick mark. If side AB is congruent to side DE and side BC is congruent to side EF and side AC is congruent to side DF. If all of that is true, if you see three pairs of tick marks showing congruence between two triangles, then we can write the congruency statement triangle ABC is congruent to triangle DEF. We don't have to prove anything about the angles if we know all three pairs of sides are congruent. So now let's get into proving triangles are congruent with the side, side, side angle theorem, or SSS. So I'm gonna skip 1 and 2. I'm gonna go right to number 3. And so I'm given this diagram. I've got two triangles that are connected. They share a side. So given given segment AC is congruent to segment AD and CB is congruent to DB, I need to prove that triangle ABC is congruent to triangle ABD. So when we write two-column proofs, we know it's important to start out with our given information. So I'm going to list both characteristics of this diagram. I'm also going to label what I know. So AC is congruent to AD. And CB is congruent to DB. Now I'm going to put those pieces of information in my proof, with the reason, of course, being that's given. And CB is congruent to DB. So since I'm only trying to prove the triangles are congruent with the side, side, side angle or congruence theorem, I only have one pair of sides left to prove. And so you can notice in this diagram, it looks like the two triangles are connected with a shared side, and that's side AB. So technically, they're the same shape and size. Side AB on one of the triangles is congruent to side AB on the other. And so since it's the shared side, it's the same side, we're using the reflexive property of congruence. Basically the same part is congruent to the same part. Reflexive property of congruence. And so now we have three pairs of sides that are congruent to each other. That's all the information we need to write our congruency statement, to write our prove statement. Triangle ABC is congruent to triangle ABD. And the reason, side, side, side. And that's it. For additional practice with side, side, side proofs, try out problems 1 and 2. So now let's talk about our other congruence theorem for today. It's called the side angle side, or SAS, congruence theorem. So this one's a little different. If two sides and the included angle, so we've got two sides in the diagram we see here and here, and the included angle. Included angle just means the angle that's in between the sides. So angle B, angle E. If two sides and the included angle of one triangle is congruent to two sides and the included angle of another triangle, then we can say that the two triangles are congruent. So let's write this out. If side AB is congruent to side DE, and then our included angle, angle B, is congruent to angle E. Let me add segment marks here. Angle B is congruent to angle E. And side BC is congruent to side EF. Then our congruency statement would be valid. Triangle ABC is congruent to triangle DEF. So let's try out a proof with that information. Let's go to number 6. So number 6, I am given V is the midpoint of WZ and XY. That's all I'm given. And then using that information, I need to prove that triangle WXV is congruent to triangle ZYV. So I'm going to start by labeling what I know in the diagram. So V, this point right in the middle, is the midpoint of WZ. Here's WZ. And it's the midpoint of XY. Use a different color here. Here's X, XY. And so let's just start. We've got our given statement. Reason is given. And then our second statement says WV is congruent to ZV. Now, that would be true because V is the midpoint. If V is the midpoint of that segment, it means it cuts it into two congruent parts. So I'm going to say that's the definition of a midpoint, because that's what midpoints do. And I'm going to mark that on my diagram. WV and ZV are congruent. Then I'm going to say that angle WVX is congruent to ZVY. WVX and ZVY are congruent. The reason being, well, they're angles that are directly across from each other, and that's what happens when two segments cross. You form vertical angles, and vertical angles are congruent. So the reason being, we could say vertical angle theorem. Vertical angle theorem. If two angles are vertical angles, then they are congruent to each other. Next statement. Well, we're still not done with this V is the midpoint business. So V is also the midpoint of XY. And because of that, it's cut that segment into two parts, two congruent parts. So XV is congruent to YV, and the reason is the same. It's just definition of a midpoint. So if you look at these triangles now, I now see two pairs of congruent sides, and the included angle is congruent. So I can now prove that triangle WXV is congruent to ZYV using the side angle side congruence theorem. For additional practice, try out 4, 5, and 7. And that's it for our video. Thanks again for watching. Make sure you try out the additional practice problems. Definitely try out at least a couple proofs. Check your answers with my filled-in notes later on, and ask for support and math help desk if you need it. Thanks again for watching. Have a great day.